Hello everyone, my name is Victor. I'm a developer advocate at ClearML, and I'm here today with Ayush.
Hey everyone, I'm Ayush. I'm a machine learning engineer at Ultralytics.
Awesome. And so today Ayush has actually not been using ClearML so far, so it's actually my honor to be the first one to introduce you a little bit to what ClearML can do in YOLOv8. So if you can just share your screen, I'll walk you through like a little quick start on just to show you what ClearML can do. Especially in the second part, we'll go into remote execution of experiments, which I think is very fascinating. And if you have any questions, Ayush, on the side or like throughout, just interrupt me. Otherwise, I'll just keep talking forever.
Sure.
So that also might not be ideal.
Awesome.
I've sent you a notebook.
Yep.
Step one is basically just the very, very basics of ClearML, right?
Mm-hmm.
So you see in cell one, we'll install ClearML, TensorBoard, and Ultralytics.
Yep.
You can do that now if you want to. So TensorBoard is basically necessary because we're actually capturing all of the scalars that are logged.
Mm-hmm.
To TensorBoard, we're capturing those.
Right.
In a future version, we might actually do this without the TensorBoard dependency, but for now it's there. And then we have a browser login. So this is essentially going to ask you to log in into ClearML. I think you're probably already logged in right now.
So I'm logged into this pixel, right? Okay, it sounds like.
Yep. So if you're just logged in a different tab, that should be fine. Be aware though that if you're running like ad blockers or any kind of cross-site blockers or even just Firefox out of the box, it will actually block that. It will ask you for just API keys, which you can easily generate, but that's the downside. This makes it a little bit easier, but it'll still ask you for them.
Okay.
And then the next cell is quite simply running your code actually, right? So it's YOLOv8 and training a model for 3 epochs. So if we do that, we'll actually see that ClearML will add like a little additions to the output to send you to the logging page of the ClearML web UI. So essentially what it's doing is like it's capturing as much as it can during the training process and sending it all to like a central server for experiment management.
Oh, I see it here.
Yep, perfect. So that actually has the ID, and then below that you have the link as well. So if you click that, perfect. If you click that, you'll actually see the console logs immediately. And so you have a few tabs here, right? You have execution, configuration, artifacts. So there's a lot here to unpack, but obviously console is pretty obvious, like it's all of the console output. Execution, if you can go to that tab as well. This is actually all of the stuff that's required for part 2 later on, where we want to do remote execution. So at any point when you run an experiment, even in a Colab notebook, the idea of us is to try and capture as much as possible, right? So in this case, for example, we just ran a Colab notebook that is not in a GitHub environment, so we can't actually get the repository, but if it was in a Git, it'd be here. And what we do instead is create like this colab.py file. And if you click on uncommitted changes on the left there, you'll see that those changes are what's in the notebook itself.
Oh, I see. Okay.
Right? So we're basically on the fly turning this, sorry?
So I can use this to like basically reproduce the same experiment.
Exactly. Yeah. So on the fly, we're keeping track of all the cells you run. It's just so it's always reproducible, just like you said. Okay. And then we also keep track of installed packages, and you can even specify some container that you want to run it in later on if you wanted to.
Okay. Yeah.
The interesting part as well is configuration, because that's where the magic happens, right? That's where you actually start training the model. And what we do is we capture basically all of the parameters that YOLOv8 might have. So that's the idea, is capture all of that so that even with the code, everything is still reproducible, even if like external parameters came in or anything. The other artifacts, under artifacts, you have the notebook itself. So later on, the actual trained model will end up in there, which makes a lot of sense. But right now it's just a notebook. So you actually have the IPython notebook itself. And then on the left, you have the notebook preview as well, which is an HTML version of that notebook if you just want to look through it, but not actually run anything. So
I can open it up.
Feel free to click the link.
Oh, nice. Okay.
So this is just for you to kind of go through and see what you did back then. The info tab is like a relatively simple tab. It just shows like how long ago it was run, when it was run, on which machine it was run, how many cores it had, stuff like that. Console output we've already seen.
Yep.
And then hopefully if the model, the model is currently on its first epoch, so you should in scalars already see, there we go.
Yeah.
So in scalars, you should already see some stuff. So you have the losses there because the training side of the epoch has already been done.
Yep.
But obviously you'll get the metrics there as well, like the MAP and others while it's being run. I'm not sure if it's running on a GPU actually. It might be running on a CPU.
I think so too, because let me see. It should show up in the logs. Okay, I think it's CPU.
Mm-hmm.
But
but that's not an issue. Actually, later on, we'll be running it on a remote machine. And that's actually a very good reason to start a remote machine on the GPU instead, is to try and get that to work way faster, right?
Yeah.
So I see that it should be now on epoch like number 2.
Yeah.
So hopefully if we go to the scalars, you will see, and you click on the right top.
Yeah.
On the right top, you have like this little arrow with the arrows around it. Oh, perfect. So it automatically updated.
Yeah.
That's the auto refresh.
Okay.
So it triggered automatically, but you can also trigger it by clicking it. It's something that not a lot of people know. So it's a really cool little extra. And so you see here like the different losses that are through the epochs, and then the MAP and everything are there as well. Like, so these are the kind of numbers that you tend to use when training these models, right?
Yep, exactly. Yeah. The maps are most important. Yeah, obviously.
Yeah, especially. And then under the plot section, and like that's the next section or the next tab, let's say, there's no data yet. So only when the training has been done, like completed, all of the plots, like the label correllogram and like the others that YOLOv8 automatically produces, and like the PR curve and everything, they're all added there.
Okay, makes sense. Yeah.
And then debug samples is the last one. So if you click on that, you'll see, I think there should be debug samples at least coming in later on.
Okay.
But if you go to, I think you had a previous version as well, right? That you've already run.
Yeah, I think so. I'm not sure how many of them actually completed, but yeah, let me see. In the projects?
Yep, I think so. And then on the YOLOv8, you see the one running that we're currently running, and then the other ones were from you, I think. So the debug samples in there will be like the actual images with the bounding boxes that YOLO produces, that you can use to go over iterations and see like what changed during those iterations.
Okay, I think I have this for an experiment. I'll see if... Okay, I think it's... is this one? Any of these?
Yeah, it's exactly this one. Yeah, it's the mosaics. I think YOLOv8 had actually a lot more like different visual outputs, and I think you guys are probably working on getting a lot of those in there as well. Yeah,
so like there was a higher degree of control in terms of what you could log. I mean, there was not a higher degree of control. It was like you could log everything. But with this YOLOv8, we have like specific callbacks for adding specific things, which sort of makes it a little bit more complicated, but it's like sort of more maintainable. So we settle with that.
Awesome. Yeah. And then obviously it's an experiment manager, so you could select multiple of those experiments and then like click compare and go through all of the like the metrics, let's say, and then compare them across the two. So now you have like the bottom ribbon.
Yeah. So how do I click compare?
Yeah. So that one down in the ribbon that actually that popped up right there. You have the compare button.
Yep.
Exactly. And then here. Yeah, you can go to scalars. You can go to basically any tab that you want. In the scalars, every scalar that is the same in both experiments will be plotted on the same plot, right? So now not all the MAPs will be on the same plot, but every MAP trace will be compared in its own plot to the MAP trace of the other experiment.
Yep. Yeah, I can see there are two plots two lines in each plot.
Yep, so that's how you compare them. Something that is very interesting to me is if you go to, like on the left top, you have the add experiment button, and then you also have the graph right next to that, like a graph drop down. So a little bit down. Yep, there we go. And then don't add an extra experiment just yet.
Okay.
But in the button right next to the add experiment button, you have the graph, and if you click that open and go to the I don't remember by the max values or the last values, any of the two. Yep. Then you can actually see that also single scalars are compared there as well. So for example, on the left you have summary, which you don't have yet in the one that that you run because it's like a newer version. But in the summary, for example, you have gigaflops and parameters and speed, And especially speed is really, really interesting to be able to compare. But it's a single number, so you can't actually do that on a plot, which is why you have to go to the max values.
Yeah.
Which is a thing that a lot of people tend to overlook, but it's still very, very interesting to compare.
Yeah, it makes sense to compare the scalars. You cannot really do them in graphs. So yeah.
No, exactly. All right. So then, if we go back to our step 1, I think we're probably pretty close to done because it's only 3 iterations.
Yep.
Okay, perfect. So what I wanted to do with the second notebook, if we can go to there, is extend this a little bit, right? Because what we've done so far is we've logged everything.
Yep.
But we can't actually change any of those parameters, right? Because the way we build ClearML in using your API actually in YOLOv8 is that we can't actually override any of those parameters from within the logger, right? That makes sense, I think.
Yeah.
To do it this way. So in step 2, what we can do is actually create the ClearML task ahead of time in our script, override or like define all of the parameters in our script. And then when ClearML actually wants to rerun that experiment remotely, we can actually do that and we can access all of the parameters before Ultralytics even comes into play.
Yep.
Right? That's the main idea here. Right. So I think we first have to log it.
Yeah. So and by parameters, you just mean the configurations, right? The configuration files.
Exactly. Yes. Yeah. So for example, the amount of epochs, the amount of like augmentation that you want to do. So that kind of, it's just a dictionary, right? In Python in the end.
Yep.
So the main idea is that we can actually take that dictionary in and log it, just like you see here. But we can also use that dictionary and like override any of the parameters. I'll show you in a bit how you can actually do that. I think in step 2, you'll actually have to log in first.
Yeah. Should we wait for this step 1 to finish or?
Not necessarily. You can actually have as many of them running as you want. ClearML doesn't really care about that much.
No, I was talking about the Colab because you cannot run 2 Colabs, right?
Oh yeah, I think Colab you can actually do more than one instance on CPU, but not on GPU.
Oh, so
this one, you can leave this on CPU as well.
Okay.
We'll actually just run the agent, the remote machine, on GPU to make it a lot faster.
Sounds good. Okay.
Okay, in the meantime, so while it's installing, let's get the agent that will be running as like a remote machine. And you can find that on our GitHub. So if you just Google on ClearML GitHub, it should get you there. Yep, perfect. And then if you go into the README and a little bit more down, you'll see there you have like friendly tutorials to get you started at the bottom of your screen currently. And there's like step 1, step 2, step 3. And if you can just open step 2 in Colab, that'll be perfect.
Step 2 or step 3? Step 2, right?
Step 2. Step 2.
Okay, sounds good.
Because what step 2 is essentially going to do, so this is like a whole getting started script, right? So there's like a lot of explanations there. But basically there's only 3 cells. So you're going to have to log in again, which is under the setup. If you scroll a little down, you'll encounter it. It's the same thing as before, right? It's the ClearML browser login. If you logged in, fine. You can also use your API key. So feel free to start running those already.
Okay, so I should run this, right? Okay.
Yeah, you should run this. Oh, wait, before you do this, let's change this runtime to a GPU one, just to make it interesting.
Okay.
You can do that under runtime or notebook settings. Yeah, perfect.
Okay.
The reason that we want to do this is because the idea of this remote execution, right, is you have your own machine, which is going to be our notebook step 2, the one that we just started like installing everything.
Yeah.
And then there is the second machine, which could be like a remote cluster or like a heavy machine somewhere else that you have to like share between multiple people. That would be this, right? So we're just using this with Colab notebooks for now, just to make it easy.
Yeah.
But ideally, you'd be running this code in like a very heavy machine.
Yeah.
In the CLI, or for example.
Yeah.
And if you scroll a little down, so you can queue up those two to be to install everything, and then if you perfect.
Oh, it's already
run that.
It's the same.
You can already install that.
Okay.
Perfect. And then the agent itself. So this is actually all you need to do, right? So it's just a pip install of ClearML agent, and then if you run this command, which is ClearML agent daemon, that will basically start listening to ClearML for any jobs that it should work on.
Oh, okay.
Right?
Yeah.
Yep. So as you can see, we have our worker in itself, and then you have the ID, and then the name is default. And that is actually the name of a queue. So ClearML works with a system of workers and queues. Actually, if you go to ClearML, you'll be able to see that very easily. So if you go to the ClearML web UI, ClearML tab, all the way at the left, you have all of these icons. There's one, the second to last, starting from the bottom.
Yep.
You have, there we go. If you click on that one, that's the workers and queues tab.
Okay.
Right?
Yeah.
As you can see, this is the available worker that is currently our notebook. Right? If you click on that, perfect, you'll see under the queues tab which queues it's attached to. In this case, it's just default, right? If you go all the way up top, you have the queues tab as well, next to the workers tab, perfect. You have the new queue button, so you can create like infinitely many queues if you wanted to. And you could create like, usually what we see people do is like you have a machine with, for example, 4 GPUs, so you create like a 4 GPU queue. And then you have machines with like only CPUs, so you have like a CPU queue, and then you can know which machine your system, your experiment will run on based on that queue, right?
Yep, makes sense. Yep.
So as you can see here, you have like the queue default with one worker currently listening to it.
Yeah.
If we go back to step 2, we actually have to get our task in this queue for this agent to work on, right? So this agent is currently just waiting for work.
Yeah.
That comes into that queue. Right, so if we log in, perfect, and then run this task, you can already run it, and I'll just walk you through what actually happens here.
Yeah, sure. Okay, so I'll just run this.
Okay, actually, before I go any further, I explained that I'm going to talk a lot, but do you have any questions in the meantime?
Not yet. Yeah. So but basically, you're gonna walk me through this part, right?
Yes,
Okay.
exactly.
Yeah.
So the idea is that with ClearML, you always start with what we call like the 2 lines of code, the magic 2 lines of code. And the idea is it's just task.init, like basically import the task from ClearML import task, and then task.init. And the task.initialize will in the back hook into as many things as it can. For example, to get the console logs, for example, to get all of the plots, right? So this is the kind of stuff that we also added in the integration internally.
Okay.
But you can do it from the outside as well.
Right.
And then to be able to actually override parameters from the UI, which we will do later, you actually have to do this way before everything else starts, right?
Right.
And the way this works is if you, for example, see on line 10 and 11, you have the model variant. It's just a Python variable that we assign.
Right.
And then we set that parameter in the task itself. Now what happens is if later we go into this task and change this parameter, this is the line where that parameter will be overwritten by ClearML.
Okay. Makes sense.
That makes sense?
Yep.
Okay. So we actually do exactly the same thing a little more down in like at line 18 and 19. Oh, perfect. It's already working.
Yeah.
So in line 18 and 19, you'll see that we create a dictionary of all the parameters that we want to be able to override.
Yep.
And then connect that to the task, right?
Okay.
And then the model just trains on those parameters. Now, ideally, you'd have all of the default parameters of YOLO in that dictionary so that on a later moment, you can override any of them.
Yep.
In this case, we'll only be able to override either the data or the epochs.
Yeah. I think there should be a way to do that later, because, yeah, I think so. But yeah, I'll check that once this is all working. Yeah.
Okay, perfect.
Yeah.
And so now what we can actually do is we don't even have to wait for this to end. We can. It's actually almost done. But if we go to ClearML now, or like to the link in the... you can also go to the experiment manager on the left there. It's a little brain icon. Yeah, perfect. That was the little brain icon on the left.
Okay, on the left.
For the experiment manager. No worries. And then under tests, you will find that we have one task running, which is the one that we saw before, right?
Okay. Yeah, so this is project test, and inside the project test, there is one task, which is also called test. So that's why we have like...
Exactly.
Okay, got it.
Exactly. And so it's essentially the same thing. It's just like with a different name, with a different project at this point. But the goal of doing this in a separate project is now that we can have a clear overview of how we can actually edit the parameters and like train it remotely. So if you actually go to the web UI here and you right click on the test experiment, right? It's on the experiment itself.
Yep.
Oh, I think you went. Yeah, you are currently in the test. So then if you click on the hamburger icon, like all the way at the right top.
Yep.
Yep. You can actually clone the experiment, which is the second to last option there.
Yeah.
And this is where the magic happens, right? So let's just keep the project, keep the name, a clone of test is perfect, and just actually clone the experiment. It'll send you to a new task that is in draft mode, right? I think yeah, perfect. A new task that is in draft mode. So if you now go to the configuration tab within the experiment, any of these parameters are now editable.
Okay, all of these.
So by the right, yeah, so on the right top, you have this edit button. And yeah, you can click that if you want. Yes. And then obviously I said all of them, technically all of them are overridable or like editable, but only the ones that we have connected to our task are actually going to change in real life, right? So in this case, the only things we can change are the amount of epochs and the data, right? Because that's the only two that we added in our dictionary in the original task.
Yep.
Right, so you can change the data by removing the path, but keeping the coco128.yaml, just having only coco128, because it's going to be running on a different machine.
Yeah.
We don't want any of the paths to be there still, right?
Yeah. We could
so perfect, and then
VOC dataset you want. We could also use VOC dataset. I think it's doable for like few epochs, like 2 or 3.
Sure. Yeah, feel free.
Yeah. And then I should also change epochs to something smaller because it's a larger dataset. So I'll just do 2. Make sense?
Sure. Perfect. Makes sense.
Right.
Right. And then you can just click save.
Okay.
On the right button.
Yep.
Perfect.
Yeah.
So what this actually did is just change the internal structure of this experiment, right? So remember, this draft experiment actually just has, if you go to the execution tab, you'll see it. This has all of the information to run this code remotely, right?
Right. Yep.
And now we also have overridden the parameters. So the only thing we should now be able to do, and there always might be an issue, obviously, but if you right-click on the clone of tests in the left pane or like the left side of the screen.
Yep.
And yeah, there we go. And you click on the right, then you have enqueue one item. And in this way, you can actually pop this experiment with its changed parameters into the queue. Okay. We can just leave the queue as default because that's the one that our worker is currently working on. And that should be it. So now it's pending, and then in just a little while, it should switch to running because the agent should take it on. There we go. And so now, if you go to the notebook, you'll see that it's actually starting to install packages to be able to run this. There we go.
Yep.
So it picked up that like the task. It's now going to reinstall all of the packages. It's going to reinstate your code, which is essentially the notebook that we first used.
Yep.
And then it should run this notebook, but it should also inject these new parameters inside as well.
Yep.
And yeah, the cool thing is you can sorry?
Should I see something? Okay, I see the spike in CPU and GPU usage right here.
Yeah, there you go. So in the workers and queue tabs, you should be able to see it as well as in the experiment view as well. So in the experiment view, if you go to like the little brain icon again, you should be able to see everything come into the test project just right there. So even in the console logs, all of the console logs should be exactly the same as they are in the notebook because currently it's just installing packages.
Yep.
And then also once it starts actually training, all of the scalars will come in real time as well.
Okay. Yep.
Right. So do you have any more questions while we wait?
So I just wanted to understand a little bit about, the remote execution. So so what exactly happening here is that I change the values through the dashboard, and then it basically executes the same code, right? But with the changed values.
Yes.
So the main, the crux of it is somewhere here because, because you're getting args from tasks, or okay, so these are hard-coded, right? So if it's just using the same thing, how is it picking it up, like the things that I've changed? Well, it's hard-coded here.
Yeah, because that's actually a very good question, because it's running inside this agent, right? It's running inside this ClearML agent, and the agent actually knows which variables are coming from the ClearML server. So we changed this in the UI, right? We changed, for example, the amount of epochs in the UI.
Yep.
So on line 19,
Okay.
there will also be line 19 in the ClearML agent. It will run exactly the same code. But then on line 19, the agent will say in this connect function, it will say, hey, in the arguments or in the args dict, I have a value of 10, but I'm getting a value of 2 from the UI.
Right.
And so I'm actually going to swap those out.
Yeah.
And that means that from the point of line 19 onwards, the args.epochs, let's say, is going to be 2 in Python as well. Like we're actually overriding that value.
Okay. Yeah. Okay. I see. So all the arguments that task.connect sees, it will sort of make sure the UI values get superseded from the default values, right?
Yeah.
Okay.
Exactly. And that's exactly why we need to do that here.
Yeah.
Because when we do that, imagine we do that like from within Ultralytics, right? From within our own place in the logger. At that point, Ultralytics will have already used some of these parameters. So even if we are able to change them, they won't change in time for the whole thing to like
it makes sense.
be edited, basically.
Yep, makes sense. Let's see the tasks. Okay, so it's
it can probably take a while. So maybe we should pause the video here and then come back once it's done executing, and we'll see the results.
I'm not sure. Like maybe using VOC might have been too much, but I don't think it's reached there at this point. It's
no. It's usually that quiet. It just takes a little time. Like that's just the downside of this kind of remote execution.
Yeah. So it has more dependencies, right? Other than
because it's installing everything from scratch, right? So that's kind of the downside is you have to build your your whole environment every time. Now, obviously, ClearML agent is cached. So if you're running the same environment over and over and over again, it will become quite substantially faster.
Yeah.
But until then, like this is the first time we've run this ClearML agent. This is the first time the notebook has seen that kind of environment. So it has to like pull in all the dependencies and spin everything up for you.
Yeah.
So that's kind of a downside. Like not necessarily downside. It's just something you can't get around, right? If it's a Docker container, you have to do the same thing.
Yeah, obviously. There's no free lunch. Okay. We have. We could show plots a little bit because now it's
perfect
populated.
Okay, so while we wait, we can actually go through the experiments that have been completed before.
Yeah.
And so we can actually see some of the plots. So these are the kind of plots you would use while training and like getting feedback, right?
Yeah. So like we have like in most of the scalars we have dynamic charts, right? So they update over time, but the plots are static charts. We don't really use them too much, but one that's really important is confusion matrix plot, because if it looks the way it does right now, it's almost good because it's a diagonal line, and so there are not a lot of outliers. So this is just like a sanity check. It's not that we keep looking at it, but once experiment is done, it's like it's like a good sanity check that everything's going good. Yeah. And these curves, all of them, like it's not for sort of looking at them all the time. The experiment's done for comparing stuff. It's just like just a sanity check that everything is almost as it should be. So it's good to have like a second check after the scalars, but the most important thing is the metrics that we get from scalars, which is the maps and the losses and all of that, which we use to figure out whether the model is overfitting, whether it's good enough,
Yeah, but that makes a lot of sense. And actually, you raise a very good point in saying that like the scalars are dynamic plots that come in over time.
Yep.
Well, these are the kind of plots that actually are generated once, and then you just use them as a sanity check. That's also the difference between the scalar step and the plot step in ClearML. So that's kind of the split you make, is saying scalars are things that come in every iteration or like every X iterations, and you want to be able to see them come in live, essentially.
Right.
While as plots are either images or what we also tend to use like Plotly, for plotting what could have been like Matplotlib images. So like we actually have a class that can basically take in Matplotlib images and create like an interactive one instead. So you actually can have interactive plots in the plot section, but it's usually these one-off generated plots and not the ones that come in over time while the model is training.
Yep, I see. Yeah. So I mean, I could have like an interactive seaborn chart, but of course it comes just once and it doesn't update over.
Yeah, exactly. That's the idea.
Okay.
And debug samples the same thing, right? Debug samples is just also as a sanity check. It sometimes can take a little while to load. But it's as a sanity check, essentially saying like every iteration you can log like an image or an audio file or a video file, just to make sure that while you're going through your iterations, you can actually see your changes and like see that the model is actually learning.
Yeah, of course. This is the mosaics are useful to see like if the labels are correctly plotted and our training data is actually correct. Because sometimes what happens is you get labels and they are not formatted properly, and then you end up sort of training it for 2 days, and then you realize, okay, the data set was the problem. And so the mosaic definitely very helpful in that case.
Yeah, for sure. And actually, out of interest, I don't know how long it's going to be running for still. You can probably go to the console or like indeed to the agent as well to see, okay, so it started.
Yep.
It started training, so that's indeed good. In the meantime, there's one more thing that I can show you if you're interested, and that is reporting. So it's actually not part of, it's not been part of ClearML yet, but it's like very new, so I'm very excited about it. But if you go to, for example, one of the experiments, in the plot section or in the scalar section, you'll see that, there, for example, you have like the scalars, and that's pretty new, but it's fine.
I can go here. Yeah, no problem.
Yeah, sure.
Yeah.
So if you take, for example, the metrics and you hover over it, what you'll see is there's like this orange button in the top right.
Yep.
You can click on Compy Embed Code. And if you click on that, it'll ask you to either do it in external tour or in the ClearML report. And if you click ClearML report, then you can go all the way at the left in the bar with all the icons.
Yep.
You'll see like the little report. Yeah, there we go. And if you click now on like new report, you will create a new one. You can call it anything you want. YOLOv8. There we go. Create report. You can put it inside of the YOLOv8 project if you want. You can put it wherever you want.
Okay.
Okay, perfect. And then if you start editing the report, you can actually paste the link that you just copied. And it's essentially an iframe, right?
Yeah.
And then if you click on show preview, it'll actually show you the plot as it's being handled by the backend.
Okay.
So the cool thing about this is that this is dynamic still, right? It's an iframe. So that means that if anything updates, it will update in a report as well. And obviously on the left, you can add as many like markdown stuff as you want. But you can also go around and like capture and gather different assets from different experiments and put them in this format.
So like I can write stuff and like have these plots, interactive plots in the same place, right?
Yep, exactly. And so it can be plots, it can be scalars like we just saw, it can be debug samples as well. So there's like a lot of different assets from within the ClearML space that you can just use. And you should be able to add. So I think if you click save now, you should be able to like get a report itself. It might be that you need like an extra line break because of the way that Markdown works, that it just, wants HTML separate from normal. Yeah, there we go.
Okay,
from normal.
It's working.
There we go. And so we see people like using this for all kind of stuff. Obviously, like you have the titles and like different plots and you can compare. Now we are thinking of building a querying system into this, which is awesome. So you can actually say, give me a report. So inside your report, you would be able to say, give me the scalars of like the best 3 performing tasks in this project. And that will dynamically update based on the best 3 tasks in that.
Great idea.
In the project.
Yeah.
Awesome. So we can see that it's working currently. I should be able to see the losses coming in as well.
Okay.
But that will take probably a little time because it can depending on how the GPU utilization is for Colab.
I forgot to change the batch size. It's too small.
Ideally you would be running like the ClearML agent on like any powerful machine. That has like a very, very dedicated amount of GPUs. But you can do like we did right here with Colab as well for some free GPU compute, right?
Yep.
Easily.
No, I see the classification loss coming in already, I think. Yeah, and the box full.
Perfect.
So
But those logs will only come in like and in the steps, right? So it's like only at the end of an epoch you'll actually get like the MAPs and everything.
yes.
So that will probably take a little while, I imagine.
Yep. Yeah. At least a few minutes because it's. Oh wow! It's
For 4 hours.
It's not using GPU. Like I think it's using GPU. Okay. Yeah.
I mean, it should be, yeah.
Oh, we didn't set the device equals, but that should not be a problem.
No, so normally ClearML agent will detect that you have a GPU and actually run it on the GPU as well.
Oh, I think I know what's
think-
happening. I think the hyperparameter here is been set to. Okay, it's none, so it should pick up.
Oh, I see.
Not sure.
Sorry?
I guess this is the main problem.
Yeah, probably. Because if you go to info on the info tab, what you'll see, if you scroll a little down, you should be able to see what the accelerator was that was in. So GPU count is 0. So it actually did not detect the GPU. Maybe we didn't reboot the machine once you gave it a GPU. That could have been the issue.
Yeah, could be, but it's at least it's definitely working. It's just the GPU thing. Yeah.
Yep.
Okay.
Okay, awesome. So do you have any more questions before we end this tree?
Nope. That's it.
Okay, awesome. So thank you all for watching.
Yep.
Thank you, Ayush, for going here and exploring ClearML with me. And thank you all for your attention. So thank you very much and see you next time. Bye-bye.
Yeah. Bye.